Okay. Excuse me. So our notes for today are special kinds of factoring with trinomials. It's okay. So the first one is a perfect square, and we did multiplying these out when you had x plus 4 squared. But what we're going to do is actually factor it to get it factored out. So perfect square trinomial is the result of factoring, is the result of squaring this out. What we're going to do is we're going to work backwards from that. So what I told you the other day is to multiply x plus 4 squared. There was a shortcut. You square the first term, you multiply the 2, and double it to get the middle term, and then you square the last term. Okay. What we're going to do today is we're going to work going the other direction. Okay. I am not terribly concerned with being able to factor it as a perfect square, because you can always use this, what we did over here, to do the factoring. Okay. The next one, on the other hand, the difference of squares. You absolutely need to be able to recognize this is difference of two squares. You cannot factor the difference of two squares easily with this. It's actually harder to do with the Xbox than recognizing that you have two squares. Okay? And the difference of two squares, two perfect squares being subtracted. So if I have a perfect square minus a perfect square, that's the difference of two squares. A perfect square minus a perfect square. So, for example, x squared is a perfect square. 36 is a perfect square. Okay. What do I square to get x squared? I square x. What do I square to get 36? 6. So my factors would be the square root of the first one, x, minus what I squared to get the second one, and the first one plus the second one. Exactly the same except for plus and minus. Remember what I told you when we did the multiplying of this last time I saw you a week ago? We spoiled it out. We did the shortcut. Oh, it's exactly the same except for plus and minus. Your factors, when it's the difference of two squares, will be exactly the same except for plus and minus. Now, factoring, and these are all perfect squares. There's two ways to do this. The way I'd like to have everybody be able to do is recognize, first of all, that it's a perfect square. That is a perfect square, right? K squared, perfect square. 64 is a perfect square. What number do I square to get 64? 8. Okay. So this should be k plus 8 squared. I need to know for sure. If I multiply these two here, k times 8, and double it, do I get my middle term? I do. That tells me it's a perfect square. Now, do I have to do it this way on here? No. I could go, and I would have 64 here and 16 here. And I'd want to have two numbers to multiply to give me 64, that add to give me 16, and that would be 8 and 8, which would give me k plus 8 and k plus 8. I could do that. Okay. So I have a look at the next one. Is this a perfect square? Is this a perfect square? Yeah. What is the square root of 16? 4. If I double it, do I get 8? Yeah. One important thing, though. This is not w plus 4. This one would be w minus 4 squared, because that's negative. If your middle term is negative, then it's a minus whatever. Your middle term's plus, it's plus whatever. Okay. Once again, could you set up the big X and do it this way? Sure. 16 minus 8, negative 4, and negative 4. Okay. And it would work. That would give me the same answer. This would give me W minus 4 and W minus 4, which guess what is W minus 4 squared. Okay, so it'll give you the same thing in the end. It's nice if you can recognize it's a perfect square. I'd like to have you recognize it's a perfect square. It shows me that you're recognizing patterns, which a lot of math is being able to recognize patterns. Okay? But it's not always. And sometimes you don't have to get where you want to go. So I want you to try both of these. Try and factor both of these. Give them a shot real quick. Okay, that should be enough time to be able to take care of those two. So this first one, x squared is a perfect square. I square x to get that. 36 is a perfect square. I square 6. If I multiply the 2 and double it, I get 12. So this is a perfect square. This would be x minus 6 squared. This one's a little trickier, but I have to go, okay, 4x squared. I square 2x to get that. I square 2 to get the 4. I square x to get the x squared. And on this one over here, I square it to get 9. I have 3. Now, if I multiply these two together, 2 times 3 gives me 6x. I double that, I get 12. This is 2x plus 3 squared. Once again, if you wanted to set this up, it would be just fine with me. It would work. Okay? Yes. You're right. It's a 2. My bad. Thank you. It's not a cube, and I wouldn't do that to you. Okay. But you could set up the Xbox that way. 4 times 9, you'd get 36 and 12, which would be 6 and 6. And you'd have to divide both of those by 4, which would reduce down to 3 over 2, which would give you 2x plus 3 and 2x plus 3. You'd get the same thing if you did it that way. Okay. These, on the other hand, setting them up in the Xbox thing really doesn't work well. For example, this one here, you would have negative 81 and 0 because you don't have an x term. So you want two numbers to multiply to 81 and add to give me 0. Not an easy thing to do. But if you recognize this as, ooh, that's x squared and that's 9 squared, a square minus a square, that's the square root of the first minus the second one, square root of the first plus the square root of the second one. 3 squared gives me 9. X plus 3, x minus 3. And once again, it doesn't matter if I have this or that. Either one of those would be fine. Okay? What? You're right, 9. 3. Why don't I put 3? You're right, it should be 9. I know why. Why did I put 3? Because I saw the 9 there, and I was thinking it was that one. X plus 9, x minus 9. That's my bad. Sorry. I saw the 9, and I was thinking, ooh, square root of 9. No. So if I do that on here, let's see. 9x squared, that's a perfect square. 25 is a perfect square. I have a square minus a square. Square root of 9x squared, 3x. Okay, what do I square to get 9? I square 3. What do I square to get x? Square, I square x. And then this would be square root of 25, bless you, would be 5. So I have 3x minus 5, 3x plus 5. If you recognize the pattern, these are easy. If you don't recognize the pattern, they're really hard. You've got to recognize the shortcuts on these. Okay, so let's finish this up. We get y squared here. We have 7 squared for the second one. So it's y minus 7, y plus 7. And once again, you could have these two swapped. Put the plus minus 7 in the front and the minus 7 in the back. It doesn't matter which one comes first. This one's a little trickier. With the 49, that's 7c. Square root of 1 is 1, so this is 7c plus 1, 7c minus 1. 1 is the square that throws everybody off for some reason, but it's the easiest square to do. Questions?